If I can just introduce at a high level the two speakers. The cooperative was founded 2 years ago. Charlie Phillips, who's speaking tonight, was the first employee and is the technical lead. Following that, EcoMaster are going to talk to us. So they've been in operation for over 15 years. They've assessed and retrofitted thousands of Australian homes. So Maurice Beinat will draw this vast experience to speak to us tonight on insulation. If I can hand over now to Charlie, who's going to do the first talk.
So thanks for that introduction, David. Again, my name is Charlie Phillips. So I'm the operations manager at Earthworker Smart Energy Co-op. We're part of the broader Earthworker ecosystem of worker co-ops here in Victoria. So we have a presence in Gippsland, manufacturing hot water systems powered by a reclaim heat pump. I'm sure many of you may have been aware of either reclaim or Earthworker before. We've been around for about 20 years now in various capacities. I would really like to thank whoever drew up this fantastic pyramid. I was looking at it before I got up today and really loved, and might have to copy some of its elements for assessments, because I really think it illustrates the crux of the issue. You've got the low-hanging fruit, and then you've got the really low-hanging fruit. I would call of making your home energy efficient, and I think we should also be thinking about this in a broader sense, making our communities more energy efficient, and our cities and our state and of course our country. If we look to the third level of the pyramid, we've got what we've just been describing, draft proofing, which is what I'm going to talk about. So I've already introduced ESCC. We've done, I think I was looking tonight, about 112 draft proofing installs of individual homes, many more assessments, well over 112. We're also a contractor to Marybeck City Council at the moment, conducting draft proofing installs, and we've worked with a number of social housing organisations. And these are some of the services we do, not just draft proofing, secondary glazing as well, and home assessments. What are drafts? Well, here we have two examples in the extremes of winter and summer. To think of it simply, we've got a young lady here in winter. She's cold. The cold air is coming into the home through various air leaks, but also the hot air that she's trying to warm up the house with is escaping. And it's also mingling, of course, with both the air that's coming in, so she's running her heating all the time, never feels very comfortable. Very common issue here in Melbourne. We have very poor housing stock, and it results in quite an uncomfortable winter we've just experienced. The inverse, of course, happens in summer. Her cool air that she's using through her aircon perhaps is escaping and hot air is coming in. We all know the feeling of being far too hot in your home in summer and perhaps escaping to the cinema or the library. Really, that's not a good solution. We are a very rich country here and we should be able to be comfortable in our homes, particularly for those who are elderly or sick in any way. It's just not a solution. So why fixed drafts? I think we've covered the emissions and money side of it with our pyramid. Lower heating and cooling, that's one of the main drivers. The other major driver, and I guess part of the title of this event tonight, is comfort. So you feel a lot warmer in winter and cooler in summer. There's also various, I guess, health co-benefits that result out of better thermal comfort in the home. And there's various other health benefits as well with reducing smoke in the home if it's bushfire season. I remember the bushfires of a couple of years ago and our homes were very smoky. It was not very pleasant. That was also a workplace safety issue as well, which Earthworker has actually been a part of assisting the union movement in understanding those issues. Dust, pollen, insects. We've draft-proofed homes to stop scorpions coming into people's houses. Scorpions are actually native to Victoria, which I wasn't aware of until very recently. You can also be quieter, of course, with reduced air leakage. Your home's energy rating will go up drastically. And of course, it helps the environment. It reduces our personal carbon footprint. So here is a fantastic diagram from Sustainability Victoria that really, I guess, shows all main draft sources. Everyone should know the issue with drafty doors. I think most of us will be aware of that. Windows as well, but there's also various numbers of areas where drafts can enter from, and many, of course, we aren't aware of until we look for them or get a professional to find them. Speaking of looking for them, sometimes you'll have an obvious gap around a door, you might have a rattle or a whistle. You could also feel for cold or moving air. So if you're coming home tonight is fairly cold, maybe even lick your finger and place it around the door or window and you might feel that cold air. So that's something to do. Or you can ask a professional, get a professional assessment. They'll identify every draft source in your home and also specify a treatment. Speaking of treatments, how to prevent them. We seal up those gaps and cracks. Wall vents are a big one here in Melbourne. Installing good seals on the bottom of doors, perimeter seals around the perimeter of a door or a window. Insulating and also sealing. A sealing hatch cover is often a missed opportunity that should be done, particularly if you're getting a professional insulation installed. Make sure they do that. You can also zone out areas so your heating and cooling is more efficient. You don't want to be heating or cooling your laundry or your toilet. No one needs a comfortable laundry. So zoning out those areas with a draft proofing treatment can increase the efficiency. Very important point here for us in Australia in particular is make it good quality. The stick-on stuff that you buy from Bunnings is cheap for a reason. It'll fall off, it'll degrade, it'll get crushed up by the door that is getting squashed in the door jamb. It's really, I think, prevented a lot of people from properly draft proofing their homes by being sold and marketed poor products from Bunnings. I think I can say Bunnings, I'm not going to get in trouble if I say them.
No, it's true.
And maybe Bowen's and other major retailers that exist in them. EcoMaster's been around for a long time. They've done fantastic work at creating good quality products for the DIYer. So if you're DIY inclined, go to their website. They've got everything you need and hundreds and thousands of videos showing you exactly how to do it. Or you can talk to a professional like ESCC and we can specify it for you. Quick warning, a gas appliance such as this one, if it's open fluid, they require a supply of fresh air from outside for your own safety. This is to ensure that carbon monoxide doesn't build up in the home. You have a supply of make-up air that can mingle with the carbon monoxide that might be accumulating over time. So don't draft proof your home if you've got something like this. Make sure it's been serviced in the last 2 years. Maybe get a carbon monoxide sensor. And ideally, start a plan to probably get rid of these heaters. In the future, we don't want these in our homes, to be perfectly honest. But if you need to hold on to it, those are the two first options. Make sure there's some ventilation and possibly get a monoxide sensor as well. Similar issue with mould. To be honest, if you have a mouldy home, stop everything and make sure that problem is solved before you do any upgrades on your home, to be honest. This is a particularly bad example I found in Frankston a couple of days ago. But you may have some mould accumulating around your windows. You can always get a professional opinion on how to stop that mould growth. There's a common issue of small mould that you might notice if you have metal windows. Mould loves metal windows. They also love dirty architraves because it's a food source. So if you have condensation as well, that's a source of water. The bacteria and the dirt is a source of food. So keep those areas clean if you can. That should prevent mould from accumulating. So how would you do a good draft proofing install? This is an example of a product that EcoMaster retails and ESCC can install, and of course person with a DIY interest can do as well. So it's a draft dodger, it sits on the door jamb as opposed to in the door getting wedged. It's got a German manufactured seal that the door compresses onto, and in this case it's a powder coated aluminium. It's going to last for a long time and doesn't need to be painted at all. So, and it's of course matches the colour of your door jamb. Sealing under a door, perhaps you might want a brush seal that's colour matched with your door as well. This is a brand new home in Brunswick East. You can see the sort of trendy rust coloured metal door, but have a look on the left, a massive gap that the builder has allowed in this home, so drafts are just whistling down the hall. So we quickly came in and popped on a sweep seal that matches the colour of the door. So that's something, again, a DIY can do and buy products from EcoMaster if you're interested. Windows. There's many ways to skin a cat with a window and many more window types. So there's a list there. I just wanted to show our lovely Lucas, our lead installer, very proud of his work. This is a bit more of a premium solution, replacing the staff bead with an integrated seal. It's something that's probably better for a carpenter or skilled labourer to do, but again, it's perfectly within the realm of possibility to DIY this, and there's a few different types, various different ways you can seal. Sealing up gaps, cracks and wall vents. The first thing I would say is please don't use a cheap gap filler from a major retailer. These cheap gap fillers are again cheap for a reason. They crack under pressure on the home and they can crumble away, not very nice. Some of them are probably a little bit toxic as well, they smell a bit funny. I would recommend a product like Fuller Seal Ultra Clear. It's fantastic, it's flexible, it's easy to work with, it cleans up easy, I love it. I use it every day, and there's me identifying a skirting crack just for you to see, and of course a cat watching me do it very intently. This is a bit of a really bad one in terms of an assessment. So we often hear ourselves saying this, so many of our homes in Melbourne are like tents, but to be honest, if you see from these photos, that's a gas ducted boot of the ducts from the floor. We've removed the cover, and that's what you can see. This little sliver of light here is underneath the house, that's gravel, and you can see again these little dots, not a great photo, but this is light from underneath the home. So in fact, in this case, it's kind of worse than a tent because you wouldn't have holes this large in a tent. So this is a really bad example, but really demonstrates that there's so many areas where large amounts of draughts might be travelling through. And of course, that ducted heating outlet is just heating underneath the home as opposed to the home itself. So pretty bad situation there. I wanted to add some local examples. A couple of clients have very generously given me permission to use some photos of their homes. These are two different examples. One in Glen Iris, a bit more of a maybe mid-century interwar period frontage with a new build Renault at the back. And we also have maybe a more familiar Camberwellian, Montalbot, Edwardian home. This one was particularly large and had about 20 double-hung windows, I think, from memory. So on the left, I don't think I have any more photos, but all these double-hung windows, aka sash windows, are very drafty. There's plenty of points and they really need a lot of work. So if you have some of these windows, which are very common, just have a look at them and I'm sure you'll be able to find some drafts very quickly. Here's the Glen Iris home. In actually the newer part of the house, we've got, hard to see in this photo, but there's a large amount of air coming through the French doors, which are quite relatively new. So there's a fair amount of treatment that needs to be done on a French door such as this, and we've done some perimeter work and fixed the centre gap and I think the bottom as well on the exterior side. We've come across a lot of bad installs on our time from other organisations, of course. You may be familiar with the door knockers who'd like to install some stuff for free. Usually they're free for a reason, unfortunately. In this case, on the right, he or she who's installed it hasn't bothered to do the whole door. I think the door was too large for the seal that they had come with, so they just popped it on where they could and ran away. And the same thing on the left, they've sort of chopped it up into various bits to fit around various door hardware, and I think on the left side it was coming off already. So often they won't clean the door and we'll stick it on and it'll fall off after a couple of weeks, usually. So that's a real shame because that's government funded installs, but that's the reality at the moment. So that's just something to watch out for. If you do get a door knocker and you want some free draft sealing work, just keep an eye on them. Maybe ask them a few questions. Maybe say, what product are you using? Is it plastic? Is it aluminium? And maybe get a card from their company as well, in case stuff falls off, you can call them back to get them to replace it. This is the end of some of the final bit of bad cases scenario. Here homeowners had a go at stopping a wall vent. Not fantastic, I'd use little bits of tubing to sort of shove into the gaps. I'd use a sealant if you can, caulking gun. Of course they've forgotten about the holes there. So that's just something to watch out for. Don't just shove things into your wall vents. Try and seal them up or plaster over them. And here's a brand new door on the left that's just got a massive gap in the top. So something to keep in mind is new builds are drafty too, unfortunately. There's very poor standards of building in this country and particularly in this weather climate in Victoria. So we need to keep in mind that it's not just the older houses, it's the new ones too. Just to wrap it all up, this is the low-hanging fruit as well as insulation, which you'll hear about in a second. Draft proofing is generally one of the most cost-effective efficiency measures you can do in your home. It's permanent, it's also passive, it's not going to need maintenance, doesn't need replacing after 10 years like a reverse cycle aircon or a hot water system. And of course there are many co-benefits which we've discussed earlier. And if you're interested, as I'm sure many of you are, in lighter footprints in some of the studies and the data that's come out of Victoria, I'd highly recommend checking out Sustainability Victoria's Healthy Homes program results. The findings they found were really fascinating, not only the health benefits but also the cost benefits for the state from not accessing health services as a result of a more comfortable home. I think it was in $800 a year was roughly the figure that they came up with that was being saved. And there's also some earlier studies, the household retrofit trials, and I think the draft proofing trials were done in 2016 as well, you can check out. I think next up is insulation.
Everybody hear me? Awesome, good. All right, apologies that my son Michael couldn't make it. We had to lock him in the factory tonight, so he's taken over from the elves. This is a house that we bought, 21 years ago, I think, and the reason why we started EcoMaster, because it was horrendous. It was a nice house, still is a nice house, but it was horrendously cold, right? And you can see it cost us $2,500 for a winter, which is not much today. But back then, it seemed like an awful lot of money to spend to still be cold, right? And so that's really what caused us to start EcoMaster, was to try and figure out our own home first, right? So, yeah, we've been at it 20 years. We did 17 hard years of home assessments and retrofits. I don't know how many thousands of assessments and retrofits we did. We haven't. A lot. Anyway, along the way, we developed a bunch of stuff, right? So it's one of the things that it's one of the joys of doing what we did, was that we can just make things ourselves. If there wasn't something, we'd just make it, right? So the main thing we made was the draft dodgers, like Charlie mentioned, and we've got quite a range now for most applications. One of the weird ones is like cavity sliding door. We've got French door kits anyway, lots of stuff. And the chimney draft stopper, which is a piece of foam, rubber, but it's actually a great thing for sealing up chimneys, right? Yep. Goodbye heating vents is for all of you people getting off gas. Woohoo! Who's getting off gas here? Oh, so many. Fantastic. So if you've got the heating through the floor like Charlie was showing there, that's where the boot's fallen out. Anyway, so the goodbye heating vents is a way to seal those up so that they're not going to be a problem for you. And of course, we developed the EcoGlaze secondary glazing system, which I went just last night to fix up a little fault with one that was installed in 2011. Yeah, one little fault. Yeah, still going great. Anyway, so that's awesome. Yep. Now, if you'd like a copy of the slide deck, you can either maybe scan the QR code, or you just go to ecomaster.com.au/LFP and just fill in the form. Just put your first name and email address there and push the button, and you can download the PDF of the slide deck. Okay. All right. Just before we get into insulation, I just thought it'd be nice to understand the difference where people work. On the right-hand side is energy efficiency. Of course, you've got your pyramid, so you know all this stuff. All the things that make and use energy. And on the left-hand side, you've got the best energy of all, and that's the one that you don't have to use in the first place, right? So that's thermal efficiency, working on the actual building envelope to make it more energy efficient. Right, so we're not talking about draft proofing, even though it's a subject dear to our heart. It really is. No, we're going to talk about insulation, ceiling, underfloor and wall insulation. Now, ceiling insulation, why is it important? Because other than draft proofing, it's the single most important element in making your home energy efficient. Okay? If you don't have really good ceiling insulation, it's just not going to happen very well for you. So by the way, these are thermal images, you know, infrared images, so you can see that they show up things. Red is hotter, you know, blue is cooler. You can see the picture on your left, that's an electrical picture, right? That's an electrician in there doing that. So you can see that the electrician's been to fit the fan and the electrician's been to fit the speaker. I think that's a speaker in the ceiling. He's moved the bats and didn't put them back, right? Which is just normal, absolutely normal. Yep, so that's what we're seeing in the left-hand picture. Bats missing, okay? The blue area is good. That was summertime, right? So that's the heat coming through the ceiling where there's no insulation. The same on the right-hand side. What we see there is actually the heat coming in from around the perimeter of the room. Why is that? Because when you're fitting horrendous fibreglass insulation into the edge of the house, it's a bit unpleasant, and so you just kind of approximate it, okay? And that's what happens. So then you're going to have all this heat pouring into your house because whoever installed it didn't want to install it properly, okay? Let's just talk about R value and types of insulation. R value, R is just resistance to heat, right? Why is this important? Because at some stage you're going to get up in the roof of your own home and have a look at what you've got, right? We're going to learn about this, so you'll have fun. Maybe be careful on the ladder, okay? But just basically, right, so if you've got no insulation, okay, you've got about R 0.1 or 0.2, that's just the plasterboard, okay? Almost nothing. And then you can basically go up. Every R1 is about 50 millimetres. Your joists are about 90. You get an idea of how it builds up, right? And you can double up things to make more, basically. It's not hard. How much do you need? I think that it's about R5 for Melbourne. You can do more if you want. Three main types of insulation that you'll find in a roof. One is loose fill, which is usually cellulose, but sometimes granulated rock wool or fibreglass. You'll find bats. Well, they're going to be fibreglass usually, or sometimes polyester, and occasionally rock wool, although they tend to be expensive. And you might find some reflective insulation. Let's have a look at some. Okay, top left-hand corner. When you get in your roof, right, and have a look, figure out what's in there. We're going to have some pictures. The one on the left shows a measuring tape, right? So that's cellulose, that's paper, ground up paper. It is treated with boron and boric acid, so that means it's less likely to burn and the bugs don't want to live in it, okay? But the thing about that is the measuring tape's in there so we can see how much there is, right? Because about 50 millimetres for R1, okay? I think that's about 30 or 40 millimetres there, I can't remember exactly. But the thing about this stuff is it's pretty cheap, right? So if you want a cheap insulation, this is a pretty good bet. But it does over time, it compresses, it dishes like that between the joists and across your house, right? And it tends to fall into the eaves as well if you've got eaves, okay? So it's not such a permanent thing. You might need to get it done again and again. Down the bottom, we've got polyester. By the way, over there is polyester, right? So it's the same kind of stuff that you've probably got in your pillows. It's nice, it's people friendly. So on the bottom there you see a ceiling done with polyester bats, And on the top there, we've got the same kind of polyester bats, but there's reflective insulation on top. So these things were called concertina full bats. Can't get them anymore. But also note that it's a maintenance nightmare like that. Okay, if you're in there, if the electrician's in there trying to put the fan in, he's not going to be happy. Can't see the joists, right? Yep. So here's some more examples, right? So fiberglass bats. When you get in your roof, most likely you're going to find fiberglass bats, pink or yellow, all right? If you're going to fit fiberglass bats, you've got to have all the PPE, right? The glasses, the everything to stop the little fibres getting in you. By the way, the fiberglass industry's been great. They've been great. They've been making these things biosoluble now. So when the little fibres get in, when you breathe them in, they dissolve harmlessly in your lungs. I'm not quite sure where they go after that, after dissolving in your lungs. They don't really say. One of the things you might notice on the left-hand side picture is the variability of the bats, right? See, thick, thin, thin, thick, pretty thick here. One of the things about these bats is, like, if you're looking for how thick it is, it's a bit of a guess, like, you know, which part are you looking at, right? The other thing to notice there is that there's, you can see plasterboard, can't you? Yeah? So that's what we call bulkhead, or it's vertical ceiling, right? I'm pretty sure that what we're looking at in the back there is the grand entrance for the mansion, okay? And then the rest of the house is a bit lower. Doesn't have to be quite so grand. So that's why there's the step down. It's uninsulated, right? So not very good. Over on the right-hand side, also bulkhead is the access door, right? So you can see that the access door has actually been insulated with reflective insulation, and you can see in the back polyester bats. What does good look like? Well, all insulation that's sold has got to comply with the building code, right? And it's not going to carry a flame. But really, if you're going to do ceiling insulation, you want to think about a few things, right? So how friendly is it for you to install if you're going to do a DIY? And I hope you do. How good is it for the planet? Like, is there a recycled component in the insulation bats? How's it going to be with rodents? How easy is it to install? You know, are you going to want to handle it? So when you get up in your roof, okay, you need to figure out what insulation you've got. So before you go up, probably good to turn the power off, okay? Sometimes in the roof you find some DIY electricals which are not good, all right? If you get up there and you actually find electrical junctions that are just hanging there, not covered, better call an electrician. So yeah, get a headlamp, get some gloves, right? And a dust mask, and hop up there and have some fun. See what there is. So sometimes it's homogeneous and sometimes not, right? We'll see. Now, if you've got downlights, who's got downlights in their home? Come on. Oh, quite a lot. Ooh. Surface mounted or pendants, pretty good. Okay, downlights can be okay, but if you've got downlights, you really want to be able to insulate your ceiling properly, and the thing with downlights is, well, probably you can't, right? Because of what they are. IC4 rated downlights, they're LEDs, but they're integrated LED, they're special integrated LEDs. What that means is that you can insulate either up to it or over it. So if you've got those, then you can do a great job of insulating your ceiling. And if you don't, before you insulate your ceiling, get your downlights replaced or eliminated, okay? Well, it's easier to replace than eliminate, but sometimes it's good to eliminate too, repair the ceiling, paint it, you know, have little pendants or surface mounted lighting. So the thing to do is to establish what you've got, what works you have to do to the existing, assuming you've got some existing insulation. So often you have to make good the existing. Sometimes you have to get rid of it too. We'll see a couple of examples. And then figure out what, you know, how you're going to top it up. How much topping up do you need, right? The other thing that you want to work out is, as well as the R value of what you're going to top up with, is the width of the batts, right? Because usually we use batts in a roof, individual sections, and they come in two different widths, right? 430 and 580. So you need to figure out what's going to fit best in your roof. It's not hard, just get a measuring tape. Okay, and work out whether you're going to do it yourself, save a lot of money, watch the how-to videos, or whether you're going to, you know, pay for professional installation and run the risk of, you know, not really seeing what they're doing. Anyway, okay, so are we keeping or are we throwing this? Yeah, throwing, yeah. Yeah, that is just too bad. That is just too bad. That's got to go, right? Oh, by the way, downlights. Who's got halogen downlights still? Anybody? They used to be such a thing. Look, this electrician, he really wanted to fit these downlights where he wanted to fit them. So it's a good thing we don't do this anymore, right? Look at the scorch marks there just from the heat of the lamps, right? Okay, this one, these are downlights as well, right? So this is what happens. You put a downlight in, you take a bat, put it somewhere else, right? By the way, we did have on another slide a thing that said, like, if you've got just 5% gaps in your ceiling insulation, right, equates to a 50% degradation of the overall insulation, right? But if you've got these kinds of downlights, or this kind of arrangement where whoever's put the downlights in has put the bats aside, you've got about 20% of gaps in your ceiling insulation, all right? So it's really just makes it almost useless. Are we keeping this? Yeah, I think so. It looks all right, doesn't it? So long as it goes back. IC4 rated downlights, put back. Yep. Okay, nice. Yep. Are we keeping or throwing this? It's a bit 50-50, isn't it? Right? If you're conscientious, you could probably untangle that and lay it out, right? Yep. Okay, here's an example of a bulkhead. So where do we get these? On the end of cathedral ceilings or on a half cathedral, you've got a great big long bulkhead. Okay, so again, this is polyester. You might notice it's stapled as well as got the strapping on it. It's double duty. And also, you see some spaces are being filled in with polyester. These are old style isolite downlight covers, not legal anymore. Okay, don't worry about those. Okay, shameless plug. Polyester bats is this stuff, 85% recycled component, all right? PET bottles, basically, that are made into little fibres. These things are made, they go through an oven and the fibres are just melted together. There's no glue, right? Awesome stuff and a really great price too. Over the next couple of weeks, you want to get up and have a look, right? Who's got a timber floor? Oh yeah, a lot. Okay, all right. Concrete floors generally pretty nice to be on, but timber floors, if they're uninsulated, can be pretty bad too. So the thing is about an uninsulated timber floor is that the temperature of the floor is pretty much the temperature outside, right, under the floor, right? So when you insulate it, yeah, you save a bit of energy that normally goes through the floor, but the main difference is comfort, right? Because the temperature of the floor becomes a temperature inside rather than outside. That's why we insulate floors. And in all those years that we insulated floors, we started the underfloor insulation thing in this country. And we worked with our then supplier to actually make the roll format that is used all over now. So we've done a lot of underfloors. And in all that time, in 17 years of doing underfloors, you know how many people said, oh no, that didn't make any difference? No one. Not one. Not one client that we did underfloors for wasn't happy with it. Yep. Is it people friendly? Blah, blah, blah. Yes. Polyester is amazingly people friendly. And the other beauty of it is because of the structure of the fibres are all arranged across the roll. And that means that you can staple it, right? And that's what you see here. Staples, right? Galvanised staples. It's a great DIY project, by the way. I can see that quite a few of you are pretty slim and you'd go all right under the floor. Yeah, I reckon. Yep. Now, even good quality product can be made to look terrible. Okay, you can make a hash of it. Look at this. This is really good quality polyester, but it's been stapled straight through, so destroying the R value of it for a start, right? It's been squeezed into spaces where it wasn't meant to be squeezed, and you're creating a rodent highway, right? Really. It's just mad, right? So neatness counts with this, okay? Right. Here's another one. So this is polyester again. It's not quite as good a product as the other one, but it's still a reasonable product, but they haven't stapled it. No, that's too hard. They've put up a couple of packing straps, right? Do you think that this part is actually doing anything? Is that doing anything? You know, it's like, why bother, really? We found that at a client's place, right? We had to, instead of installing our stuff, we had to fix someone else's job first. Okay, sometimes people think it's a good idea to put fiberglass bats under a floor. This was even held up with chicken wire, right? Nothing helps. Nothing helps. It's just a mess. Look, it's just terrible. It's worse than nothing, okay? Yep. One might say, if you think you're going to work with rigid board material under an existing floor, tell them you're dreaming. Because really, you can't work with, you know, it's like, are you even going to get it through the access hole, you know? It's just, don't. Just don't, okay? Right, so we're back here, and the rule is, if it's beautiful, it's right, okay? That's beautiful, that's right, that's exactly right, yep. Fixed hard up against the floor, right? No rodents, no air supply there, nothing but insulation up against the floor, okay?
Why does it not sag?
Hang on, I'll demonstrate. Because you asked for it,
Yes.
this is why. Okay? Yep, because all the fibres are aligned this way.
Okay.
So we can separate it this way, but you're not going to, yep, that's underfloor, okay. Walls, get some wall insulation. Who knows if they got wall insulation? Yep. Who doesn't know if their house has wall insulation? Okay, quite a few, all right. How are we going to tell? So the way to tell is to take a power outlet off an external wall and have a look. You might want to turn the power off, or you might want an electrician to do that. Up to you, be safe. Take the power outlet off, have a look in the wall, take some pictures. Try not to drop your phone in the wall. Okay, yeah. I haven't dropped my phone in the wall, I've dropped other things in the wall. Anyway, so that's how you tell, right? And then what can we do about it? Well, you could take the whole end of your house off, right? But that's not really practical. By the way, the grey bat there is wall insulation, right? Because it's 90 mil thick so that it goes in a standard stud wall, right? But there's several ways that you can retrofit wall insulation. If you've got a weatherboard house, you can actually take some weatherboards off and you can shove bats in there, okay? Little sections of flexible polycarbonate that you can get from Bunnings are handy for pushing in the bats, right? And then you pull out the polycarbonate because it makes it smooth to push the bat in, okay? You put it 2 bits of polycarbonate, bat in the middle. Shove it in, pull the polycarbonate out. Yeah, repeat, rinse and repeat. So if you've got a weatherboard, you can do that. There's also companies that will pump in loose fill into wall cavities. How do they do that? Again, if it's weatherboard, they can drill holes in the weatherboards. There's usually a row about here and a row at the top, and they fill it up with granulated fiberglass insulation. The fiberglass has been treated, because fiberglass normally sucks up water, but this stuff has been treated so that it doesn't. And then the holes are plugged up, and then you've got to sand and paint, right? If you've got a brick veneer, then depends on the roof. If it's tiled roof, the tiles are pushed back over the external walls and the hose is put down the wall cavity and filled up like that. Under windows, they usually drill holes in the mortar and pump in like that. On second floors, usually they pump in from the inside, drill holes in the plasterboard. So you can see it's all, it's doable, right? It's certainly worthwhile getting wall insulation. It's a bit harder, than the ceiling. The ceiling's the easiest and the most important. If you've got a timber floor, the underfloor is a great time will be had by all doing that. And the wall insulation really, most of the time, is for a professional to pump in the granulated fiberglass. Okay. Right, resources list. Diagonal bracing that was like checked into the studs, so there were no noggins, but still, even then, if you just drill a hole at the top, the stuff may not get very well to the bottom, it may not fill very well, and so they do still drill halfway up for that as well. Yeah, and then newer ones are built with noggins, and so you have to get in under the noggin and of course in the top. It depends on the. It depends on the installer. You know it's tight if you can't roll over, okay? If you can't actually roll over, that's a tight space. Yeah, so it's about there, yes. You can get into pretty tight places, but if you're wanting professional installers, so some are more willing to do that than others, right? Some of them are just going to go, oh no, that's tight, it takes too long, yeah. So the question is about draping the ceiling insulation over the joists. Over the joists. It's a terrible idea, right? Because how much insulation is actually in touching the ceiling? Not very much is the answer, right? And so, unless you can guarantee that it's completely still airspace where it's not touching, and that rodents are not going to get in there and have a field day. And you can't guarantee those things, right?
The room is very open somewhere.
Yeah, so the question for the others is, how hard is it to staple into 100-year-old hardwood? And the answer to that is pretty hard, but nowhere near as hard as in Sydney or Queensland, where the hardwood is like twice as hard. But you do need a good trade quality stapler, like the Milwaukee cordless staplers that we have for hire. Okay. By the way, we hire them for $85 a week, as opposed to the tool hire place where they're $85 a day. The higher the R level, the higher it sits above the joists, and the propensity in that situation is for people to go, well, I probably want to insulate the joists as well, so they cross them over, right? Which from a thermal point of view is great. And what I say to that is that it's okay to do that in the sides, but don't do it in the main trafficable part of your roof, okay? Because it just makes it unmaintainable. Yeah, so any tradie that goes up there that can't find where to put their foot, it's going to be a problem. Yeah, so the question is about flat-roofed house. firstly, good for you for having some insulation in there in a flat roofed house, because usually there's not. Usually there's just the builder's blanket under the roof, or in the older days it was just a piece of tar paper sarking, which will be disintegrated by now. The answer is yes, you have to lift the roof, right? So depending on what kind of roof, if it's a regular clip lock roof, then a roofing plumber can do that. By the way, scheduling is the main issue, right? Rather it's not so much lifting the roof, it's actually scheduling, because if it's too hot, it's no good. If it's too windy, it's no good, because you lift a piece of roofing iron, it's a dangerous sail. Okay, of course, if there's a risk of rain, no good, right? So roofing plumbers are understandably reticent to take on such jobs, right? We used to do this, and we did quite a lot of flat roofs, just by having, working with a roofing plumber to lift the roof. He lifts the roof, we do the insulation, he puts that section of roof back, and we move on, right? We gave it up exactly because of that reason, because of scheduling issues. The last roof that we did, I don't know, 6 times I think we rescheduled it, 13, okay. There you go, 13 times we rescheduled that roof, and that was the limit,
So you're essentially saying it's uneconomical?
Well, it depends, It's like, are you going to continue to live in the house, or are you going to pass it on to make it someone else's problem, So if you want to stay in the house, then it's probably worth persevering with, yeah? The other thing to do, of course, is to figure out how much insulation can you put in there, right? So the usual way to do that is to find, I assume that you've got a flat ceiling under the, so the first question is how deep are the rafters, right? Because that limits how much insulation you can put in there. So knowing that, you can figure out, using the 50mm trick, what kind of R value you can achieve, right? What's the maximum R value that you can achieve, yeah? The other thing that you can do, is the roof okay? So sometimes there are some steel decks that are actually crimped together, and they can't be, they get destroyed if you lift them, You can take it up, okay, all right, yep. So I would say, work out what you can do, how much you can put in there, and I think it's worth doing, personally. What's the other 15% that's not recycled? It's what they call virgin fibre, okay? It's new plastic, and it's what they call the low melt fibre, okay? It's what actually bonds everything together.
It's really only an issue with those freestanding gas heaters, or those sort of wall gas heaters. They're the ones that are going to be possibly producing some carbon monoxide that might be leaking into the home, that's not getting flued up into the outside world. There is some concern with the ducted systems as well. I believe it's much less of a risk than the heaters that I showed prior. So plenty of homes, of course, are connected to gas as well, but not every home has those freestanding heaters. But that's where that's really our first warning, is heaters like that.
Can I just add something?
Sure.
Thanks. One of the problems with those heaters is that they are inherently dangerous, right? It's not only don't draft proof your home, but actually some draft proofing would have saved people, So some years ago there was a couple of kids actually died overnight because it was cold. Their mum left the gas heater on to keep the place warm a bit, and a pitched roof, when it was windy, right? And when the wind goes over a pitched roof, it's a bit like an aircraft wing, and it sucks air out of the roof, right? And it sucks so much air out of the roof through the bathroom exhaust fan, yeah, that it pulled the flue gas back down the flue into the house. Yeah? Yep. And there's been other people killed similar way, right? So yes, don't draft proof it, but although, you know, a simple thing like a draft stopper on the exhaust fan would have saved those kids. You know, the best idea is just get rid of that shit.
Yeah, it's a great point. I mean, in a passive house, I'm sure many of you are aware of that, the air changes, which are the amount of time the air changes itself per hour, get down to about 0.6, I think is the intended air changes. I think the average air changes for a home in Melbourne might be about 15, so many times more. If you retrofit draft proofing, you're not going to hit 0.6. The reason I mention 0.6 in passive houses, once you get to that level, you have active ventilation systems in place to be able to ventilate the home. The other thing I would say is, yes, ventilating is important. Having a healthy air quality in your home is important. You just have to have it on your terms. So when you're ready to, when you're comfortable, open a window. But don't allow air to come in all the time when you don't have control of it. So that's what we might call controlled ventilation. And the Germans have a concept for this. I don't speak German, but it's, you know, sort of Schockluften. Every day at 2 p.m. they'll open the windows for 15 minutes, whether it's, you know, -5 degrees. That's not a problem here. We can do it, you know, earlier in the day if we want, and just to let the house breathe, and then tighten back up, and then run the heating or the cooling.
I think there's no issue with draft proofing a home that's hydronically heated, right?
And insulation.
Yeah, and the same, yeah. Yes, that's a very good question. How much do you gain by trying to insulate a double brick wall? Mm-hmm. You're absolutely right. Look, if you could do it, you would gain a lot, I think, because the double brick behaves quite well in the summertime in the heat because the outside brick layer heats up, and it takes a lot of heat before the inside layer heats up. Okay, so generally pretty good in the heat, but of course terrible in the cold because no insulation at all, right? So if you could get 50 millimetres of insulation in your cavity, which is nominally what it is, 50 millimetres generally, that would make an awesome difference, right? The difficulty is in finding someone that will do it, and also because it's not really 50 millimetres, is it? Because when the brickie puts the bricks on there, you know, the mortar deck rolls inwards, you know, from both sides, and so the cavity's pretty well taken up with mortar, you know. So I think really you don't have anything that you can do with that. If you were really keen on, you know, adding insulation, the way to do it would probably be to have insulated plasterboard added to the external walls. But of course there's all the difficulty with cornices and skirtings, you know, yep, and architraves and all that stuff.
I think that's the sort of 5 minutes over on the questions. So
Okay.
if we can, but
Yep.
you can probably ask after.
Yes, happy to chat.